YouTube. Woo! Mr. King coming at you live from the 209. Here are the questions for the day. Please pause the video now and answer them. And remember, elements are found here on the periodic table. It shows all the different types of atoms that we know of in the universe. And you're going to learn today why they arranged the periodic table the way they did. Okay, cool. So go to Monday, electrons with the periodic table, and pull up these slides. So just a reminder, here's a periodic table. This is what we're going to be studying this week. You're going to learn the most simple atoms, like the first 20, and you're going to start looking for patterns. So look and try and look closely at these three elements. You have hydrogen, lithium, and sodium. Pause the video now. Try and figure out what is the same about all three of these elements. Once you think you've found something they all have in common, go back and try and find them on the periodic table. You should also notice something the elements have and similar on the periodic table. Yep. And do that for beryllium, magnesium, and calcium too. And do it for fluorine, chlorine, and bromine. I'll give you a hint. Look closely at the electrons. Something with electrons, something that we learned last week, is the answer. Next, 6 and 7 are unique. This is a new pattern. What do you notice? Boron, carbon, and nitrogen all have similarly. Same with sulfur, chlorine, and argon. I'll give you a hint. For these three, they all have the same number of blank. Try and figure it out. All the same number of blank. And then find sulfur, chlorine, and argon on the periodic table. What do you notice about those three on the periodic table? Same with boron, carbon, and nitrogen. And then I'm asking, where on the periodic table can you find elements with the same amount of valence electrons? Hint, it either has to do with groups, which go vertical, and periods, which go horizontal. So which ones, groups or periods, have elements with the same number of valence electrons? And they do the same thing, but for orbitals or rings. Where can you find atoms with the same number of orbitals? Do they go horizontal in periods or vertical in groups? And the last one is like a summary. Yep, after you do that, please take the attendance survey, and then you're all good to go. Bye, everyone. Thank you for staying with me.